Hello, everyone. I welcome you all to the third week of this massive open online course on Let Us Fight Antimicrobial Resistance. In the first 2 weeks, we have focused on the fundamentals of this topic, wherein we tried to understand about the different types of microorganisms, microbiome, and even different agents which we can use to control the growth of microorganisms. We even spoke about different chemotherapeutic agents that are available to treat infections. And now the ground is all set for us to understand what antimicrobial resistance is all about. In this third week, we will understand first what antimicrobial resistance is. We will also focus on the scenario of antimicrobial resistance in the globe and especially what is the situation in India. We will also see what are the causes of antimicrobial resistance, how human activities contribute to the spread of antimicrobial resistance. We will also notice and discuss as to how this antimicrobial resistance is gaining acceleration and is becoming a grave issue day by day. Keeping this in mind, we will be starting first with a very basic introduction about antimicrobial resistance in general. So let us begin. This first video is going to focus on the concept of antimicrobial resistance. And to understand this, it's going to be quite important for us to understand some basic terminologies like adaptation. So let us begin with a very interesting story. I'm sure that right from school, you have come across these terms like adaptation, evolution, and we have been hearing a lot of cases and examples to understand the same as well from our textbooks. And I'm going to take you back to one such example. I'm sure that you all would have heard of this term, adaptation. And I'm also sure that you would have heard of this very interesting example of how giraffes came into existence. There is this story that there were deer-like organisms which used to feed on leaves of plants. And gradually, as every condition was favorable for their survival, the number of this deer-like organisms started increasing. As the number of these animals started increasing, it was obvious that there was going to be shortage of food, because these animals, due to their height, could feed only on leaves which were there on the lower branches of the plants and trees. But as their number started rising, the leaves on all lower branches started getting exhausted. And now there was severe shortage because they were huge in number, but there was no leaves available and they couldn't reach to the higher heights of these plants or trees in order to feed themselves. Now the problem rose to such an extent that it started raising a question on their existence. Because without food, how will an organism survive, isn't it? In such a scenario, it was a question mark on their existence. And let me tell you that nature always wants to save its own creations. Nature has taken so much effort in creating every single organism that we see around us. And nature can never let its own creation just wither off like that. Nature tries its level best to bring in some changes in the physiology, in the structure of the organism, so that it gets an opportunity to survive even with changing extreme conditions. This was one such condition, wherein nature's own creation was losing its opportunity to survive. And hence, nature thought of giving them a change, an adaptation, which was an elongated neck. This elongated neck could now help these organisms to feed on the leaves which are also there on the upper branches. Nature hence tried to establish a balance so that its own creation is not lost. This is how beautiful our nature is all about. Please remember this one very, very important fact, that nature is never partial with any of its creations. Nature always gives an equal opportunity to every single creation of its to survive and manage itself even in extreme conditions. And that comes to any organism in the form of adaptation. Similarly, this is the concept that we have been learning from school, survival of the fittest. So nature may not be able to give these changes or adaptations to all the organisms of that species. That may be very difficult. But it starts with one, so that at least that individual and its offsprings can survive in those changing extreme conditions. That's how every single organism on Earth undergoes adaptations to save itself from any kind of problem or challenge that could raise a question on its existence. Now you would be saying that we are discussing about antimicrobial resistance. Why are we even talking about giraffe or adaptation for that matter? Please remember that when you use antimicrobial agents to control microorganisms, to kill them, you are raising a question on their existence. So when there is a question on the existence of these microorganisms, nature will surely bring in some changes in these organisms as well to give them an opportunity to survive. And that exactly is what antimicrobial resistance is all about. What you see on the slide right now is a normal test that is performed in any microbiology lab to see if any antimicrobial agent that you are making use of, especially if you are using an antibiotic against a bacterial species, you want to use that for treatment and you want to check if that antibiotic is able to kill the bacteria or not. This test is performed. It is very popularly called as antibiotic susceptibility test. So here you can see on the left hand side of the screen that those discs, those paper discs contain the antibiotic and it is being tested against a bacteria. So all that cream white colored growth that you see is of bacteria. And you can see that where those discs are placed, you see a clearance zone. You see that the bacteria is not able to grow around that particular disc. This shows that antibiotic is able to stop the growth of microorganism. It has some activity against the bacteria so that it's not able to grow there. But if you see the image on the right hand side, you will see that out of the 7 discs that are placed on that plate, only 3 or 4 of them are showing activity against the bacteria. The rest 3, they show negligible or no activity at all against the bacteria, which means that the bacteria is resistant to that agent which has been used in this particular scenario. This is what is happening with us. All known antibiotics that we had, we are losing them one by one because microorganisms are not getting affected at all by these antibiotics, which once upon a time were very, very strong, very, very potent in killing that bacterial species. So what is antimicrobial resistance all about? It's about microorganisms adapting, finding a way to defeat the antimicrobial agents that you make use of. That could be an antibiotic, an antifungal agent, an anti-algal agent, an anti-protozoan agent, an antiviral agent. Organisms are finding a way to defeat these antimicrobial agents. They no longer respond to these medications once they gain resistance against it. And this, of course, is going to make it very difficult for the medical personnel to treat the infections because now you do not have anything to carry out the treatment of this patient. So infections which once upon a time were treatable are turning out to be fatal. They are turning out to be lethal. Once upon a time, probably you were able to just prescribe a medication and the patient was completely all right. The patient used to recover. But now is the scenario due to antimicrobial resistance that these medications are totally useless. We are not able to make use of them. We will try and understand more about antimicrobial resistance with some selective examples in our next video tomorrow. Till then, stay tuned.